also for some members of the team who are sitting right in the middle. Yes, and so I'm talking today about Service Bus, and I'm going to start with a brief introduction for all those people who don't know yet. And then I'm going to go through a series of quick demos. If you have been in Norm Judah's foundational sessions, that will be familiar, but I'm going to show you those again. Then we're going to go a little bit through some theory of the new capabilities, and then I'm going to show you code. So the reward comes at the end with all the code samples, but before that we also need to go through some basics and some of the why we're doing things that we do. So my name is Clemens Fastas. I'm Principal Technical Lead on the Windows Azure AppFabric team, specifically on Service Bus. And I'm mostly giving the team grief about things. So that's kind of my role there. So let's go and start with why we're building this thing. Why do we build Service Bus, and why does it matter to us, and why does it matter to folks like you, we hope? It all starts with the notion of the cloud, or applications that are hosted in separate environments, where applications not only are sitting in a single data center or within the firewall of a single organization, but they span different organizations, or they live on-premise in the cloud, both of those environments. And of course, as we all hear the promise of the cloud, keynotes, foundational sessions, everybody says, yes, it's all inevitable, you will have to embrace the cloud. And then sometimes you hear things like, all applications will move to the cloud. And of course, that's completely crazy. They won't. And the reason why they won't do that is very simple. We have built, all of us, all of you, have built in the last 20, sometimes 30 years, a huge stable of applications that run inside of your enterprise in various sites, sometimes hundreds, thousands of apps that are all interconnected. What we've been selling you as infrastructure vendors and tool vendors, distributed systems tool vendors, for the last 15, 20 years is ways to go and streamline your application integration, to do EAI, to do B2B integration, to streamline your apps. So whenever you take any of these applications that are sitting in your enterprise and want to move them to the cloud, what happens is that there's tons of tethers hanging on that application. It's all the connections into all of the other apps that you suddenly need to think about. No application these days is ever an island. So it's really hard in reality to just take an application and move that up to the cloud because it's interconnected. So the purpose of Service Bus, singularly, is to provide an integration capability that works for hybrid applications, where you have applications that are hosted in the cloud and that need to interact with applications that sit on-premise, or where you have applications that are hybrid in the way that they run across data center boundaries, across organizational boundaries, or are just generally distributed across a variety of trust boundaries and network boundaries. If you look at this example, and we have very many customer samples, meanwhile, where organizations are using Service Bus in this way, what they are just telling us generally is that they have an existing web services infrastructure, and they want to take web services that are inside of their organization, and they want to go and expose them out so that they can be consumed. We have one case where we have an airline, for instance, and that airline is doing passenger check-in at airports using mobile devices now. The reason why they're doing this is because they want to be able to show up at an airport within a week's notice, set up operations for 2 weeks, and then leave again. It's big in Europe, where you have a lot of travel destinations where it's just hot for the season. So they just want to go in and out, and they don't want to have set up all the operations. They don't want to sit behind green screen terminals because that's all inefficient. If you opt into the green screen model, you often have a different system on a per airport basis. So they are running a large website today. I think it's very similar to the low-cost airlines that you have here in the US. And so they already know how to build load manifests, passenger manifests, all the different documentation that they owe the authorities. They know how to do this with their own infrastructure. So instead of doing that from the airport operations, they want to do this by themselves. So how did they do this? Well, their website is already backed by a backbone, a middleware backbone of backend services. So to start this pilot, what they did is they went into that backbone, which consists of all of .cf services. They changed the configuration file. They edited an XML file. And with that, they had all these services sitting in an externalized DMZ that is service bus for that purpose. And that is great efficiency, because they didn't have to speak to anybody, even in their own organization, for how to punch the hole, the forward hole, through their entire infrastructure. Very efficient. Now, other people say that's a job for a VPN. That's true in many cases, if you can trust all the parties. In very many cases, that's not true. Think about a franchise or a franchising organization, right? You have a chain of restaurants, and you have franchise partners, and now you go and integrate the front end, the restaurants, with your website, which is doing e-commerce, right? People can order some swings or pizza or whatever on that commerce portal, which is centralized for the organization, and then that restaurant gets notified of that order. So let's say you have 5,000 restaurants, you go and integrate all those 5,000 restaurants using a VPN. Layer 3, layer 2, network integration. What that means is that if you don't pay a lot of attention and take measures, you're now defending everybody from everybody, right? And you have some kid who goes in Dayton, Ohio, and plugs a USB stick into one of those machines at that restaurant because they're working there, and uploads a virus, right? And in San Diego, California, the pizza falls out of the oven because there's a virus over there. So yeah, all of a sudden, this VPN thing is not so attractive anymore because it doesn't work across trust boundaries that well. Most of those sites, many of those places sit behind firewalls and NATs, and it's often not practical to create integration, especially when you think about networking environments that you don't own, where you simply don't get a public IP address, right? You have a point of sale in a mall where you're getting the network environment from the mall. You're not going to have a public IP address on that point of sale. You're going to have a NAT address provided to you by that local network provider. So how can you expose an endpoint for your point of sale that you own through this store mall network? That's hard. People who are on WiMAX, here in the US Clearwire, you don't have a public IP address. If you're on 3G, you don't have a public IP address. How do you expose a web service endpoint so that someone can talk to you? So there's got to be some mechanism to deal with that. And so Service Bus is built to address those concerns. More scenarios. So the one I talked about, the airport. Others are, the last mile to the home problem. If you have devices that sit in the home, how do you get to them, right? You want to build the smart grid for electricity. You put devices into the house, and you can rely on the fact that most people will have broadband by now, or at least some kind of internet connectivity. But how do you reach those devices? Are you opening up ports on the firewall of the consumer? I don't think you will. I don't think you should. You have operations requirements where you have systems that sit in different data centers on different sites, and you want to have insight into them. You probably want to go and grab a trace log, or you want to have information about tracing. How do you consolidate all this information? How do you reach into those machines? How do you do command and control? It's all hard problems with existing infrastructure. And how do you create all these different connections in a secure fashion? So that's what Service Bus is all about. The capability that we have currently in production, predominantly, is the connectivity relay. The connectivity relay functions as follows. I'm just going to show you one picture of how that works. We have on the receiver, on the sender side, service endpoints. The receiver is just a regular .cf web service, right? You don't need to know anything new. It's just a regular .cf web service. That .cf web service, as it opens up, so you have a service host and you open that up, what that does is, instead of listening on the local network port, or on HTTP sys, or on the shared TCP listener, it walks up to the Service Bus namespace, and reserves a name. This is very analogous to how a HTTP listener talks to HTTP sys. It walks up to HTTP sys and says, I want to rent part of your namespace, and whenever there's a request coming into HTTP sys to that namespace, call me back. And your code gets a kernel callback, then translated through several layers of API, gets a kernel callback that carries that request, or to be precise, that connection. So it's registered on that namespace. The namespace is a structure that you get for you. So you can go and walk up to a portal and create a namespace. Let's say the namespace is called Clemens. Clemens.servicebus.windows.net, or in labs, clemens.servicebus.appfabriclabs.com. And that namespace, the philosophy behind that namespace is every name that can ever exist already exists. So you can walk up to the name and say, let's say /A/B, and then you can go and create an entity inside that namespace. That gives you unique names worldwide for your service. No matter where that service shows up, whether that's in a hotel, whether that's in an airport bar, whether that sits in a data center, it now has a stable name in the world. Right? Clemens.servicebus.windows.net/A/B, irrespective of where the actual network location is. So that's what that picture shows. Then a sender wants to talk to it. The sender goes and creates a connection to a front-end node on Service Bus, where it connects to what we call a forwarder. And that forwarder then says, hey, since that sits on a different machine, it says, hey, to the routing fabric, I need to know who owns this address. So walks up and sends a message to that address. That will cause a control message to flow down to the receiver. The receiver then will go and rendezvous with that forwarder, and with that we have created a relayed connection, and we flow the regular web service traffic across that. So we have a relay in the sky, and that relay allows for TCP connections, net TCP, so it's overlaid with a framing protocol that's a net framing protocol, or HTTP. What we support in this capability is HTTP, HTTPS, and net TCP. We're using outbound connections only, so you don't need to open up anything on your firewall inbound. We're using ports, outbound TCP ports, 9350 through 9354. If you don't have those open, we will detect that situation, and then we will fall back onto HTTP, which means we're creating a simulation of a bidirectional TCP socket over a pair of HTTP requests, which are plain on port 80, and then we're overlaying them with a structure that simulates TCP. So that's a connectivity relay in short terms. Now, if you've seen that already, there was nothing new. This is Service Bus as we had it so far. So what's new? What we're introducing, or what we presented yesterday, Norm Judah announced it, is we have a brand new technology preview for Windows Azure AppFabric. That's the May 2011 CTP. You can download those bits, and there's documentation on our website. We're going to have some videos that guide you through all the capabilities that we have. So there's a lot of material that's there or that's coming. But most importantly, you can now go and download the client bits. One word on versioning, because that's important. And I also want to have this on the record on for the people who are listening offline. The Service Bus has there's two versions for the SDK. And the reason why they're called 1.0 and 2.0 is because we need to disambiguate the assemblies. So the only way we can keep assemblies with the same name separate from each other in .NET is the version number. Otherwise, the version number has almost no significance. What that means is everything that's 1.0 is production. Everything that's 2.0 is future. What's going to happen, though, is that all these new capabilities are going to show up in assemblies that are going to be named 1.0. The goal that we have in our team is that everything is going to be drop-in compatible. So you will get, as we go into production with these new capabilities, you will get a new SDK, a production SDK, and you can take that Microsoft.servicebus.dll that comes, and you can drop it into an existing app that's using Service Bus, and it will just work. At the same time, existing bits, the 1.0 assembly, when we go and redeploy the service, you won't see anything. Right? We will light up tons of new capabilities under the covers, but the existing code will just work. So that's the goal that we have. So don't get confused. The TTP has a 2.0 version number, is bound to AppFabric Labs, but the future version, the one that we go into production with, is going to be bound against Windows.net, and it's going to have the 1.0 designation. It's somewhat confusing, but that's the only way, really, we can keep those assemblies apart. So what we're doing with this release is we're adding a brand new set of capabilities. It's a huge surface area that we're introducing with this release. And I can't scratch the surface, but I can't really go into depth and do everything justice. So what we're going to do is we're going to go and do some code walkthroughs, and we're going to do videos, and we're going to do all kinds of things to go and give you more information about all the things that we have here. For the Microsoft developer community, we're doing something that is very new. What we had so far, not only in Service Bus, but really up in the platform, is a built-in queuing capabilities in Windows, MSMQ. And we had publish and subscribe capabilities, obviously, in BizTalk Server. But here we're introducing, really for the first time, a pure publish-subscribe platform for Microsoft all up. And we're also introducing that first in the cloud, which is also fairly new. So the connectivity features of Service Bus are going to stay there. We still have a mission to make our service management story a lot better than it is right now. Sanghua, who's sitting here, is actually working on that very actively. So today we have a feature called the Service Registry, for instance, and in the future you will be able to query into that infrastructure. So you will be able to tag services and query them. And so we're going to give you active discovery in this way. Whoever was at Yuval Lovi's session yesterday, he talked about discovery. We're also going to use some of that infrastructure to give you continuous insight and the ability to subscribe to things that are going on inside a Service Bus. So things we're talking about inside of the team are system topics. I'm going to get back to that once I've introduced what topics mean and what they are. So we're going to get back to how we can make those areas, and how we're going to make those areas better. And then lastly, integration, transformation, routing, coordination, a lot of features that you're familiar with if you have worked with or at least looked at BizTalk Server are also going to come into Service Bus in the form of a pluggable pipeline infrastructure that we're going to talk about at the next large conferences that are coming up in fall when we're ready to talk about that capability. We're currently building it. So what I did at Norm's session is I showed a little demo. I'm going to show you that demo quickly again. Really, the question here is we have the separate sites. We have all these different ownerships, the problem that I explained to you before. How do we connect them? And the way we connect them in the middle is using, first of all, a Service Bus queue. The Service Bus queue in this picture is a queue, and you can think of that queue as like the MSMQ queue. So it's a full-featured queue with reliable messaging, with durable store at the back, and with a number of messaging-specific features, including capabilities like receiving by a certain correlation ID. So if you want to build a request-response path, you can send messages in, and then you can receive messages out based on the messages they sent in, which sets it apart really from simpler queuing infrastructures. So we're now introducing the notion of a first-class notion of a queue inside a Service Bus. The way I differentiate personally, the difference between this queue and the Windows Azure queue, there's another thing called the Windows Azure Storage queue, or Windows Azure queue, is, and that's not a contradiction in the platform, is very similar to what we have in Windows. In Windows, we have MSMQ as the messaging infrastructure, and we have name pipes, or pipes, and mail slots as something that's a lower level file system-based mechanism. So we have basically the same parallel model where we have a pub/sub infrastructure here, where the queue is part of it, and then we have the Azure queue down here. What's more interesting, so what that gives you, just generally in notion of, in terms of a pattern, is a way to decouple front-end services from backend services. And this is not only useful for on-prem to on-prem or on-prem to cloud or the other way around, but also inside of your application. So if you're building applications on the purely on the Windows Azure platform, purely in the cloud, you can use our capability to go and create, to talk from a web role to a worker role, for instance. So it's intra-application and across application, similarly suitable. So if you have a lot of storefronts, and those storefronts are pushing a lot of traffic, you put that into a queue, and the inventory, being on the pulling side of the queue, will just work on its schedule as it has capacity available, and the queue will grow and shrink depending on how the volume is. And if you need to add capacity, well, you can add capacity by adding more workers, and you can add more workers as the queue grows, and you can take more workers, you can take workers out as the queue shrinks. So one thing we don't do for that pattern yet, just to be very clear, is our queue doesn't yet expose the current length. Because measuring the length and giving you an accurate read in that situation is actually kind of is tricky, even though you might not think that it is. So we're going to have, in the next version, we're going to have the queue length that you can observe, and then you can go and build autoscale very easily on top of that. So that's the basics that a queue gives you. What's more interesting is the topic. So really the queue, and if there's any confusion or the parallel of Azure queues and AppFabric queues, really the mechanism that we expect most people to look at are the topics. A topic is a message log that you can put messages in just like a queue, but it has multiple tails. So you have a subscription, and that subscription reads from that message log, and you can go and then pull messages from it like a queue. So if you look at the straight line in the middle here, we have a data collection topic that has a subscription, and that subscription goes down to the inventory service. That line behaves exactly like a queue. The subscription behaves like a queue, the topic behaves like a queue. They're indistinguishable from the client side. But with a topic, you can now add additional tabs. So you can add another subscription that you can use, for instance, for auditing. And you're going to see, as I drop into the code later, you can see one of those examples very clearly. And then you can add other subscriptions for other purposes. For instance, for real-time analysis, real-time insight into apps. So that's one of the samples that I brought along, and that's from Norm Judah's session. So what I have here is a little point-of-sale app. And in fact, if you go to, if you were going to martview.net, that's this website here. You could, and we had that also in the Norm Judah keynote, you could go and sign up, and you could go and download this little application. It's going to do federated login. I'm not going to show how that works right now, just in the interest of time. For everybody who's viewing this offline, the interactivity will obviously not work unless you are in the time machine. So we have people who actually are playing along. This is me. And so if I go and buy more rocks, then that's going to show up. See, there's more people now showing up here who are playing along with that demo. And now what that means, what that is this is the dashboard, and now I am tapping into the stream which goes off to the inventory, which goes off to the audit log, and I'm now pulling data in real time into my app. But really, none of the pieces had to be rewritten for that purpose, right? I can go and add a tab at any point in time if I have the right permissions to do so, right? So the topics are secured, they're overlaid with the access control service, but if I have the permissions to add a subscription, for which you need to have a so-called managed permission, then you can go and simply add another tab and get more copies of that data. So what I do then is I have an analysis tool, and that analysis tool also sits on on another tab, right? And what that does is it rolls up data, and as it rolls up that data, it republishes that into a into another topic that this thing is subscribed to. So it's taking the events in, it's running this through Stream Insight, and then from Stream Insight, we're republishing every 5 seconds the roll-up of all that data. So, so you get all kinds of interesting capabilities here just by hooking things together in this way, by publishing data into a data stream and then tapping into that data stream. And then lastly, in this scenario, what I can also do, and these were all mostly things about data fan in, I can also do data fan out by having one nugget of data that I want to send to others. So I'm going to do that now, where I will go and send, one thing I should do before that is, see, as you're all helping me here, there's all my different places here. These are stores in Redmond. Let's go and let's not look at them. So I'm going to go and filter down I'm going to filter this down to Atlanta, as I should. So I'm going to filter all these messages down to Atlanta, which hopefully now worked. Or did I destroy my demo just now? No, I didn't. So now I have a filter in place. So all these topics, all those subscriptions, all those tabs can be individually filtered so that I don't get all the messages, but only really the messages I'm interested in. And what I'm only interested in right now are the messages that are coming from Atlanta, means from right here. And then lastly, what I was alluding to is I can actually go and add things. So if I go and add a cloud here, everybody who's actually playing along will now get the cloud as a new product. And if we go here, if you all go and buy clouds, you can go and buy clouds. And so this is all hooked up through our new topics infrastructure, through our new PubSub infrastructure, where we allow publish and subscribe and allow people to go and subscribe to things. I'm going to show you later how that all works. But before that, we're going to go through a little bit of theory and a little bit of information about all the basics, and then I'm going to show you the API and the code behind it. Because I should, before I confront you with all that code, I should probably tell you what this is all about. So first of all, the queue. The queue provides you with a queuing infrastructure, which has 3 protocols. I'm going to get to that in a moment. We have up to one gigabyte per queue. We're going to have 100 megabyte per queue for the CTP. It's free. And the 1 gigabyte per queue is the current thinking. We have heard that that's not enough. And so we're thinking about how much more we need. So we have some limits that we're thinking about. Currently, the thinking is 1 gigabyte. And please let us know on, for instance, the forums or over Twitter what you think, what the right quotas would be. But there's got to be some kind of limit for that. Once you create a queue that's different from the message buffer, if you've used the message buffers before, they will stay in the system. There's no TTL limit. There's no refresh. There's none of that sort. If you create a queue, the queue just exists. So that's exactly the same experience as you would have with MSMQ. It's just up in the cloud. So you create a cloud queue once, and it's just there. The maximum message size is 256K. That seems small, but we have a feature called message sessions, which allow you to flag messages, a sequence of messages with the same session ID, and those sessions then get pinned to the same consumer. So if you have a competing consumer situation, what you can do is you can go and pin those to one consumer, which can then go and take all these chunks and write those chunks to a file or into a database. So you can send a sequence of messages through the system that represent the chopped up single large message. The rationale here is that no single value that we can give you here, a message size limit, will satisfy all scenarios. If you need to haul large catalogs with 500 megabytes or 500 gigabytes even, if you need to haul insurance claim documents which have 500 pictures attached, no limit is going to help you. What you really need is effectively an unbounded size of messages and a mechanism to keep those together. So we have the session mechanism, and the session mechanism also includes a little session state store. So you can actually log what messages you have already processed. So if your consuming party goes away, whoever jumps in and fetches messages for that same session knows where that party already left off. So that actually has transactional integrity with the session facility. So the messaging, we have 3 APIs, WCF, the REST interfaces, and the messaging API. I'm going to be talking mostly about the messaging API today. And the HTTP REST interface is, for all those who have been following for some longer time, mostly for most cases or most code that we've seen, it's compatible with the existing message buffer. So if you have an existing implementation that's relying on message buffers for whatever purpose, you should be able to very easily switch over to queues. And the only major difference is in the creation code and how you create your queue. The management model is the same, but the difference is that we actually now have a proper management API that sits on top of all this. So why would you use the queues? I already talked about load leveling. And then, of course, load balancing. As said, the queue length is not there yet, but it will be. And with this, so first of all, you can have a number of receivers, and you can go and scale them up as you get more messages. Once we add the queue length, you can now go and observe the queue length. And if the queue gets too long, you spin up more workers. And as the queue length shrinks, you can go and collapse those workers. To the extent that you can have full temporal decoupling, that you can realize batching with this as well. So for instance, if you want to do batch processing, where you know that all the work that you have is kind of it's not time critical in an hourly or minute by minute sense, but you need to do a roll-up of data to write a daily report, right, or an hourly report or a monthly report. But you need to crunch through a lot of data to do that. What you can do is you can go and just accumulate all the data you need in that queue. And then at some point in time, you go in Windows, if you do this in Windows Azure, right, or if you do this in your own private cloud, you spin up the necessary workloads and let them work until the queue is drained, and then you shut them down again. So you can build, with the queue in the middle, you can now build systems where you can save quite a bit of money by just deploying the apps, and you can do this in automated fashion for as long as you really need them, and then you can go and collapse them down again. You can do that kind of in a rhythm on a daily basis, and with that only really pay for that respective compute time. And of course, the other scenario for this, the obvious other one is if you're talking to mobile devices, or if you're talking to devices that are disconnected, right? You can have a queue per target that you want to send data to, and you're decoupled from the lifetime of that target. If that target is currently out of network reach or off, you can send messages, and that target will get those messages. There are TTLs on those messages that you can set as you like. So if you send messages and you say that message won't matter anymore if that isn't delivered within the next 10 minutes, you can set the TTL, and that message will never get to that sender if it's delivered, not within the period of time. And of course, what queues also help you do is help you decouple your systems in terms of failures. You have a message that's being sent to a target process. The target process gets the message and crashes. What you want to be able to do is, and it's crashing because of some event, right? In Windows Azure, it may be that it's crashing because the Fabric controller decides in that lucky moment to take your VM into the backyard and shoot it in the head. If it does that, then your process suddenly goes away, and you don't get to complete the processing. So in all those cases, we have a mechanism for you that's called peak lock, or a peak lock retrieval, where we will get the message for you, you can go and process it, and then you label the message as complete, and only then we will go and delete the message. So it's locked for a certain period of time. And with this, and with the session facility where you can store state, you can build, even though we don't give you distributed transaction coordination support, which is a whole different topic which I could talk about for an hour, because in essence, we don't allow anybody, and you should not allow anybody, to lock your store. But with that mechanism, with peak lock and the duplicate detection that we have, we allow you to do very efficient transaction semantics on that queue. So this is ready for business. For those of you who are building ASP.NET apps or who have friends who are building ASP.NET apps, and you want to go and build that kind of flexibility in your backend, we have correlation facilities. So you can set a reply address and a correlation ID on your messages as you send them in. So you have a work queue. All the front ends put work into the work queue. You can scale up and scale down the workers. And every front end can have its own reply queue. So the worker goes and creates a message, says my reply queue is the following, sets the message ID on that message, and sends it into the work queue. A worker picks it up, does the work, labels the returned message with that correlation ID, the incoming message ID, that's the work ID, and sends that into the designated reply queue. On the front end, as it has sent the message, that thread, and it can be HTTP, basically just goes into a wait, to be precise, in a received by correlation ID for as long as you want to wait, and then you can get very easy correlation in this way. And with that, you get load decoupling, because you're never going to overstress the workers. And you get a way to actually deal with the timeout. If you say, on the front end, I'm only going to wait 10 seconds, after 10 seconds, our infrastructure returns and says, hey, I don't have a reply to you. What do you want to do now? And then there's all kinds of recovery strategies that you can do. You can, for instance, take that job and say, that job is not going to be routed to the following backend server, which will then go and actually tell the user by email about the completion of that job, and that's what you tell that user. So there's all kinds of things you can do by adding queuing, by adding topics in the middle of your apps. Topics. That's the next thing. So queuing is good. All the things you can do with the queue, you can also do with topics, but with more power. So you have a publisher, you have a topic, you have a subscription. On that subscription, which is here, you can have competing consumers as you can have on a queue. So you can add additional subscriptions, and for CTP, up to 2,000 subscriptions per topic. Every subscription is getting copies of the messages that are being sent in, so it acts like a virtual queue. So set one message in, get one message out per subscription. Subscriptions can have filters, and they can have actions. The filters, or rules as I call them, select messages based, or as they are also showing up in the API, rules select messages based on those conditions that are the filter conditions. And so you can have more than one of those rules, and every matching rule yields a copy of a message. So actually, one message into a subscription can yield multiple copies of those subscriptions. And the reason for that is that every rule also can have an action, and that action can go and modify properties of that message. So that you have a picture, the way we express those filters is done in SQL 92 syntax. The reason why it's SQL 92 syntax is A, that's familiar, and B, we're in a standardization process with a bunch of other vendors where the standardized filtering language is SQL 92, and therefore we picked this. So you can now operate on the properties of a message, think of that as headers, and you can run expressions, and those expressions are now selectors on which messages you can get from that queue. So you publish a message, and you set the properties to values, like the invoice total and the client rating. And with this, you can go and filter those out. Or consider the third one, last name like V. What you can do with this is you can go and use this for partitioning, where you send a stream in, you have some data, you promote properties out of that data, and now you can go and partition that data out by filters. The actions allow you to go and run a complex condition like this, and then add or modify a property that's already in the message to basically summarize the result of that match. So that for further processing, you already have a property that's capturing the essence of that. So for instance, if the invoice total is greater than 10,000, or the client rating is less than 3, then set the audit required to 1, which in the further routing step would then require that to go to the audit queue. So why would you use them? Publish events to many subscribers. That's very obvious by now, I hope. Each subscription can be shared by competing consumers. So you can build, if you do this partitioning scheme, you get a queue per partition if you want. You can have taps. So you can go and treat everything like a queue effectively, create all links between pieces of your system as a queue, but always have the ability to go and tap into that data flow for audit purposes, for analysis purposes, for whatever reason you want, and you can do that later. The great thing is you don't, with the API shape that we have, you don't necessarily need to make the decision early, but you can go and swap out a topic for a queue and replace that by a topic later, because we have an independent infrastructure of senders and receivers, as you'll see in a moment. So that's the partitioning piece that I talked about. You have some property, and you can go and define ranges, and then have subscriptions that only capture those ranges. All right, so code. I'm going to show you as a matter of proof, before I go to these slides, which are going to be more instructional than showing you, than scrolling through things. I'm just going to show you one example here, so that you believe me. I have here the Service Bus demo that is actually called the Publish Subscribe Sample in the SDK. If you go and download the new CTP SDK from download.microsoft.com, you will find the downloads for the SDK itself, which only contains the binaries effectively. And then you will also find the samples as a separate download. In the separate download are a number of new samples. And mind you, the product is in CTP, and the samples are also in CTP. And there have been a lot of enthusiastic folks from the product team who've been writing those samples. And since they're product team folks, they kind of know the product already. So there's one or the other sample where you kind of need to know the product to learn the product. And so we're working on that as well. So what we have here is a new construct called the Service Bus Namespace Client. The Service Bus Namespace Client is the tool that you use now, or that you will use, to create everything that lives in the namespace. Initially, in this version, you create the queue and you create the topic of the Service Bus Namespace Client. In a future release, when we're bringing back the capabilities that we talked about at PDC, namely for the relay load balancing, for instance, which we didn't include in this CTP for scheduling reasons, you will also create connection points through that same client. So I can go on that client, go and create a queue with this name. It's fairly straightforward. And once you've done that, you've created a queue. The way you authenticate against this is you have a set of credentials. We're going to do quite a bit of work on this area in the current milestone that we're now in to make those things somewhat more straightforward, to give you an easier way to do federated security here. So this is just a standard shared secret credential where you have a username effectively and a key. And so we're going to go and create a first-class federation infrastructure on this. But otherwise, you just need to know on the namespace client how to create a queue, and that gives you a queue. And that queue now sits in the system. So the namespace client allows you to create things, delete things, and get things. What it doesn't have, and that's we call this painful cut or embarrassing omission, is it doesn't have an exist method. That, yes, we know, and people have been yelled at and all this. So so the thing that's done in the samples right now is this embarrassing little piece of code. What you want to do really instead in your actual code is you want to get the queue. If you can't get the queue, then create one. I apologize on behalf of Microsoft Corporation. So once you have it, so once you have created the queue, you go to the runtime part of the world. So there's a management piece, and that's just all the Service Bus Namespace Client. That's how you create those things. and then there's a way how to interact with them. And that starts at the messaging factory. So the messaging factory is the thing that dishes out connections. And that's why it's rooted in that thing. So the messaging factory, with that, you create such a factory on the service URI. We could make that a little simpler too, with the same credentials. Once you have the factory, you create a queue client. It's the client for the queue, right? Here, you create the queue, and you interact with the queue. Here, you're actually having a client for the queue that you use to send into the queue. So those are two different concepts. And off that queue client, you can create a sender. And then we go through a list of messages that we prepared, and we can go and send those messages into the sender, which means that lands in the queue. That's all it does. So that's all fairly straightforward. If we want to receive messages, we go to the same queue client, create a receiver, right? And then we try to receive, and what this thing here does is it's using the particular try receive with a timeout of 5 seconds. So that's kind of when it gives up if it thinks that the queue is empty, and that's when there's no more messages coming in those 5 seconds. So let's go and run this quickly, so that believe me that actually exists. So it's creating the queue now, and then goes and sends those messages in. And then it's getting those messages out. Yoo-hoo, great, we have a wonderful queue that sits up in the cloud. That's all. So the API is fairly straightforward on that level. So let's go and look at that again. So there's namespace client, right? Namespace client is used to create the queue, and then also to create topics and delete topics. The namespace client has all these different operations, and it operates against that namespace. As I said earlier, this infinite structure of all names that can ever exist already exist. The namespace is also something that's showing up using REST. So if I go into my app now, or into my browser, I can go against my namespace, clemensv9.servicebus.appfabriclabs.com. And what I get here is, well, sadly, an empty feed because I didn't provide a token, the security token, so not everybody can browse it. But what you get is the root of an Atom feed, and if you provide a management token, you would do so in a programmatic client. I just want to show you that that feed is here. Then you can not only enumerate information from the namespace, and you can go and descend into that hierarchy of feeds, but you can also go and create queues with the simple REST API. What we give you with the namespace client is effectively just a queued overlay over that REST API. So you can create queues from virtually any platform that supports REST if you do the right incantations in HTTP REST. And over time, as we are in this CTP, we're going to show you exactly how that works in all kinds of different platforms. So runtime API choices, what I showed you was the green piece, the messaging API. I'm going to show you a little bit more about that too. On top of that also sits the WCF service model, and specifically that then sitting on top of a binding called the Service Bus messaging binding. So in addition to the bindings that we already have for Service Bus, NetTCP relay binding, WSHTTP relay binding, basic HTTP relay binding, all those relay bindings, we now also have a messaging binding. The Service Bus messaging binding, based on the fact the name roots in the fact that we have a Service Bus specific messaging protocol right now, and it's the messaging binding. So that's how the name comes in. And then in addition to this, we also have the HTTP REST protocol. So you have a choice of how you want to use this. You can go and use WCF, as I'll show you in a little while, or you can use the messaging API. The choices are, if you go and use the messaging API, you get access to all the underlying features, everything that we have, right? It's a low-level API. Low-level in the sense, that's what I just showed you was as low-level as it gets, is that you don't have all the convenience of WCF with dispatch and with formatters and all those things sitting in there, but you get fairly good control of all the messaging aspects that you want, and you get all the transaction integration and all the pieces and the session support. really where you can twiddle with all those things. We have exposed most of those things on WebCF, but not all of them. Also, a significant difference. I don't know whether I show you that. So here's the messaging factory. Do I have one of those? No, I don't. But that's great. So I have that on the next slide. So the messaging factory, as I showed you, is the thing where it starts. It creates the client for sending and receiving messages. Now, why do we need that factory? Why can't I just say new queue client? The reason for that is that there's a connection manager sitting inside the messaging factory that's trying to pool connections and trying to create as few connections as we can into Service Bus. And therefore, we have this one infrastructure, and we also need to go and reconnect to Service Buses eventually, etc., which we're not doing right now. So this is why this is all gated by this messaging factory. And the queue client, subscription client, topic client then yield the objects that you actually interact with, that you send messages through, and that's the message sender, the message receiver, and the session receiver. So how do you send messages? Well, you create, as I just showed you, this is a simpler version of it. You create the factory, you create the queue client based on the name. The name here is default queue. Mapped onto the namespace, this is, let's say, clemens.servicebus.appfabriclabs.com/default queue. So the name here is a relative path into your namespace. And then you can create a message sender, and you send a brokered message. The brokered message is different from the WCF message. There's a whole talk that I will see whether I can go and record this. I'm going to do next week. That's called Messages. And it's talking about the impedance mismatch between all kinds of different messaging models, including the one that we're just introducing. Why is that so? Why don't you use the WCF message? And you can believe me, there have been great discussions, and I went into those discussions with, are you crazy? We should be using the WCF message class. And they convinced me. So the thing is, the brokered message, the messaging message, really is a container for arbitrary binary payloads that are annotated with properties. That is the same as the HTTP message. So funnily, we have a REST versus SOAP story here, just in the same way, but it's messaging versus SOAP. Because SOAP messages are payloads, right? SOAP messages are in the payloads of a framing message, and so the frame may be HTTP, but the frame may also be the messaging message that we have here. You can go and take the SOAP message and promote data out of it and stick that into the properties, but really there's a containment mismatch here, where SOAP messages are meant to be transport independent, but in order not to lose all the fidelity of the transport itself needs to have a first-class thing, and this is what we're finding out in the REST world, right? Where people say, hey, in REST, I want to have all the capabilities of HTTP, and so we're building a special REST HTTP programming model. Glenn Block is having a session about this, I think, here. And we're also building this special messaging model, which doesn't mean that SOAP is not important anymore. You can use WCF services, you can use the bindings as I showed you, but the low-level API has its special message. So, and then, so you can create the message, as you can see here, and you can go and set the label, you can set the time to live, and you have a effectively arbitrary size bag of properties you can set on those messages. And what's best practice in the messaging community, the JMS API, the Java Messaging Services APIs, look very much like this, is a lot of messages simply don't have a body, right? We can have a body, but a lot of messages just don't have one because a few properties are sufficient. The great thing about the properties is you can filter them on subscriptions, right? And the body is just effectively a blob that you have to promote stuff out to into properties if you want to go and filter on them. But that's the way how you send messages. Receiving messages, just as simple. You have a queue client, you create a receiver, and then you have a various number of receive functions. There's asynchronous versions, which are difficult to put on slides. There are try functions that will not throw at you. There are receive functions like here. They will infinitely block. You have ones with timeouts that will go and throw at you. You have filtered receives where you can say receive by correlation ID, and you get the messages just by correlation ID. So there's all kinds of different variations of receive functions that you have. on here for all kinds of scenarios. And what you see on top, in the top box, is a receive and delete. This is a destructive read, right? You read the message, the message has gone away. What you see in the other case is a peak lock, where we're getting the message, we're taking it, we're then processing that message in some way in our code, and then we're calling complete, and complete will go and then complete that message, which means that message now goes back into the that message now gets deleted from the queue because we're done with processing. If you say abandon, we're increasing a count on that message, on a property, and there's a sample in the SDK, in the samples directory, called dead lettering, or dead letter queue, that shows how to deal with poison messages and how to deal with dead letter messages. We're currently letting you, and this is a CTP, do the dead letter message handling explicitly, like what happens with messages that will always fail, poison, dead letter, and all those things. So there's an explicit handling right now, and we're looking to automate this as you are familiar with more sophisticated messaging systems as we make progress. Sessions, the session facility. The way you send into sessions is fairly simple. There's a session ID on a message, and as long as you set the same session ID on the message, you just have the same session, right? There's no API to create a session. You just make up a unique identifier. A GUID is convenient, but you can also make something that's more permanent. And then you create a queue, and the queue needs to be created as session full, or the topic needs to be created as session full. There's a special flag on it. And you send messages, and you send that session ID. What that's causing is, if you go and accept a session receiver like this, there's also a way to accept a session receiver with a specific session ID if you want to resume a session. But if you accept a session receiver like this, it's like a message receiver. What happens is that on the server, that session gets pinned to your network session. So you can have many sessions multiplexed on the server. As soon as you, as the one receiver, the one having that message that network session, are pinned to that one, all the messages belong to you, and any concurrent receivers only get the other sessions. So you get an exclusive lock on that message and all future messages with that same message ID. And that's done with this simple API. In that session, you can also, and that's the second little call that we have here, the set state. With set state, you can go and now set state into that session, indicating what you have already processed. So if you want to keep a log of all those messages that you have already processed, or you want to have some other indicator of progress, how far you're done with that session, you can go and always synchronously do and save that state. And the reason why that's in the API, why we even have that feature, is because Workflow is using it. So the Windows Workflow Foundation, as it will be hosted in the cloud, will be using that facility to actually keep state around and see how it's doing progress in the back end. And that's a capability that we will be using like under the covers in the grand version of Office 365. So topic, so that was the queue. There's a lot more features. I actually cut out several slides here, unfortunately, because I already have 56. Another feature that's worth mentioning, for instance, is scheduled messages. You can create a message and say, deliver this message at the following time. You can put that into the queue. The message doesn't even show up in the queue. At that given time, we activate that message and make it available. So, which means you can create a timer with this very easily. Just put a message in and say, deliver this message tomorrow at 12, and tomorrow at 12, the message shows up. So topics, you create a topic client, you create a sender, you create a message, and you send it. So up to this point, the topic is exactly like a queue. This is interchangeable code. In fact, if you notice, between this, right, create a queue client, and create a sender, and that, there's really no difference. So you can have some code that goes and basically says, give me the thing I need to send to. And if that's a topic, give me a client for the topic. If that's a client, a queue, give me a client for the queue. But the code that actually sends, the only reference it needs is the message sender. So it doesn't even need knowledge of this. So it gives you a very nice decoupling from the concrete thing. And then you can go and send that message. On the receiver side, I said you can go and create those rules. I'm going to show you that in a moment. You create a subscription client that's like the queue client on the receiving side. On the subscription, on your named subscription, all the subscriptions are named on your topic. And then, just like with the queue, same story, you create a receiver. If the topic is session-oriented, you accept the session receiver. And then you can go and use all the receive functions. So again, that is fairly straightforward. The subscriptions can be filtered. So you create a subscription, and then you can add a so this is happening against a namespace client, obviously. So you can add a subscription with some name and a match all filter expression. That's the simplest one. That's just getting everything. With that, you get a topic subscription that behaves like a queue. Or you can say, here's a filter expression. If the color is blue and the brush size is 10, these are properties that would have to be promoted on the message. Then you can go and apply that filter expression. That's interesting. That's not exactly third normal form here in the code. And then you can also set a correlation filter expression. And that is a filter expression that explicitly hooks to the correlation ID, so you don't have to write that code with correlation ID equals so-and-so. That's a simpler form to express that. So writing those filters is really, really simple. And then you have those actions. That's the thing I showed you in the previous slide. So if the support package is premium or the severity is smaller than 1, then set the priority to 1 and set the importance to high. So that's how you can go and modify those things. So you create a rule description with a new filter action. Or here you create something that's a conditional one. So you can actually create rules that will always modify your messages. You can create rules that will conditionally modify your messages. Or you can create rules that don't modify your messages at all, but simply go and filter and give you copies. So I could obviously go on for several sessions with drilling into the details. That's why we have the samples that we're going to give to you, and promise we're going to go and blog and write more about this. And we have the whole team that's committed to interact with you in the forums. And we're trying to do a good job at that, because we're realizing we're releasing a brand new big surface area. And we really, really, really need to have your feedback, because we ultimately have 3-4 months to get it right. So we're listening on the forums and whatever Twitter, whatever mechanisms we have. We're really, really interested in getting some data on what you think about that particular API. The other API is actually fairly straightforward. It's the WCF service model, and we have a service bus messaging binding, and that service bus messaging binding I'm going to show you in another sample, I hope. Let's see and find it. There is a WCF service sample. That's the one. And by now, you hopefully believe me that things actually work. But in case you don't. So here's that. Someone needs to make a run this program thing in Visual Studio. So I just sent those messages. Those messages arrived. So what this is a simple one-way communication channel through the service bus messaging binding. So let's look at the anatomy of that thing. It is really simple. The sender here just creates a standard, very simple, as far as WCF is simple, client, channel factory with a contract. The channel factory relies on some config. Wouldn't be WCF, it wouldn't rely on some config. And So it has the endpoint definition. The address is Clemens v9 servicebus@appfabriclabs.com/pingq. So that's actually related to that queue. The binding is the service bus messaging binding. There's some details here that we're configuring with the send timeout and the receive timeout, so you have control over those. The contract is the ping service contract that I have in this app. And I'm applying the transport credentials here. I'm also doing that in code, but that shows you just how you do that. You can do them in either way. And then you create the channel, and then you start sending messages using that contract. So that happens in the send messages function right here. We create the ping data. This is just a data structure that's serializable, and then we just send that data. So the contract for this is sitting in. Where do I have the contract actually? Oh, here's the data. So there's the ping data, it's just a message. And we have a contract, and that's the contract. And so that's just a normal .cf programming model. The message is SOAP, and you get all the capabilities of SOAP messaging, but just through a queue. So this is the son brother of the net MSMQ binding, right? It's effectively what you get in terms of those capabilities. Also, MSMQ also has session support in a similar, not exactly in the same way, as our queue. And so in the same way there, you get session support here. If your queue is sessionful, we're giving you a session channel. And if you accept it, if internally the .cf service is sessionful and accepts a session, you get this pinned behavior, right? You get all the messages only of that session are getting spooled into your clients, and concurrent receivers, competing receivers, are receiving those too. The way we're implementing this .cf infrastructure is we have this we get this default behavior, or sorry, this default binding here that we're configuring. We actually have two things that we have. We have a service bus. These are the config parts of it. We have a binding and we have a transport binding element. So the standard binding that we have and that I've configured into this app, sorry, wrong file, into this app here, has a standard encoder already. So if you want to have flexibility, as you can do in .cf, you can actually go and plug a different encoder inside of it, so you can control whether it's text or binary. So you could theoretically even build a scenario where you send text SOAP messages, or text anything messages really, because you don't have to use SOAP with .cf. Any messages, you can receive them with .cf, but you can send them using the native API or vice versa. This gets even more interesting if you want to receive using .cf, and if you want to send using, let's say, an iPhone, where you don't have that. So you can go and publish through the REST API, but you can receive through the .cf API. Right? So there's all these combinations. We have three APIs, messaging, .cf, and HTTP REST, and you can use all those three fairly interchangeably. So that already brings me to the end, and that's actually quite good, because we can probably field one or two questions, because I need to rush out right away after the session and get to the next one, which is on the other side of the world, and need to be there. So AppFabric all up is the new middle tier. You've been seeing some of the overview sessions. There will be an overview session that I'll be doing in B314 in half an hour, so rush. Be slower than me, though. And so it's there to build real apps, to actually address all the challenges you have with hybrid applications. We have this infrastructure in the cloud, don't forget that. So all the applications can actually reach all these messaging capabilities from anywhere you are. We think about ourselves as the enabler for hybrid applications, and to build apps that embrace the internet and are federating between the cloud and on-premise, and between on-premise and on-premise, and between separate parties. And for that, we also federate with the access control service, which is an important part. So that brings me to hopefully the question, well, I don't find the question slide, so let me address that question. Yeah.
Okay, just wanted to check on a couple of things. Event correlation and rules. Can I
Yes.
trigger rules based on the presence of multiple events, even if the order 1 was received first and payment was received 3 hours later? I can then trigger another event to be published as a result of the correlation of the two.
So that would be could be complex event processing, and for that you would have to go and put Stream Insight into the middle. So you would have to build something like what we showed in the demo, where you have a complex event processing system right in the middle of it, and we're working on this as a to enable that directly.
And how would I specify rules to run in parallel? Like if I have 100 different rules that need to execute, and then another rule after that, so I could run the first one.
Oh yeah, we don't do chaining. We don't. It's not a chained rules engine. That's not what it's for.
Okay. And then as far as the business rules being in SQL, I've seen systems before where the entire business layer is in the data tier embedded in stored procedures, and that was a bad idea. So
it's just the syntax. So we actually compile that down to link, and we're going to give you the ability to express that in link in the future.
Thank you.
Right. All right. So I think that's what I had. Related sessions. There's some interactive sessions that are going on. I only picked the ones that are in the future. My session in MID 314, which is kind of a prelude to this, and then tomorrow an introduction to composite applications that we're also going to queue in the next one. If you want to get the SDK, go to in this Azure AppFabric overview over there. You can also find that very conveniently through Bing and through downloading this deck. And if you want to go and play with the system, the way you create a new namespace is you go to https://portal.appfabriclabs.com, create a namespace, and you can go and party. With that, I thank you very much for your attention. And don't forget to complete the evaluations in a hopefully favorable way. And whether you do that in a favorable way is not going to affect whether you can win an Xbox 360 or all kinds of other wonderful goodies. And with that, I thank you for your attention. Thank you very much.